2 raised to the power 2. 4 over 4. Hence, 1 equal to 1. If we let n equal to 2, that means 2 here means the first and second term. Hence, in this left hand side of this equation, you have 1 over 3 plus 2 over 3 is equal to, for this, you substitute the value of n. Hence, you have 2 over 2, 2 plus 1 over 2, all over 4. Hence, this will give you 8 plus 1, 9. If you simplify this, it will give you 9. Hence, it is true for this. You can also go ahead to show for maybe the last one. For n equal to 3, meaning the first term, second, and third. Then this side outside of the equation, substitute the value of 3. Hence, if you have 3 power 2, n plus 1, 2 over 4. Sorry, this n should be 3. If we simplify this thing further, you see that it is true also. Whatever you have here, you will be equal to whatever we will be having here. 3 raised to power 3, 27. Right?
Yes.
27 plus 8. 35. 35 plus 1. 36. Hence you have 36. Simplify this. It will still give you 36. Because this thing, 2 plus 1 is 3. And 3 raised to the power 2 is 9. 9 times 9 divided by 4 to give you 36. So the next thing is you assume that it is true for what? Assume for n equal to k. Hence, from this you are now substituting the value of all this as k. Hence you have 1 over 3 plus 2 over 3 plus 3 over 3 plus k. Instead of writing n, now substitute the value of k and here as k equals k over 2, k plus 1 over 2 all over 4. Right? Then after this, you prove for n equal to n. You prove for n equal to k plus 1. Hence, everything here. Hence, you have 1 over 3 plus 2 over 3 plus 3 over 3 plus k plus the next term, which is k plus 1 over 3 equals. So, after writing out this, when you get to this point, it means this k n plus 1. From this now, this is for n equal to k. It substituted the value of all this. So now we are now substituting the value of n for k plus 1. That means we want to prove for the next step after k. Now this is hence you have k plus 1. Raised to the power what? 2. And for this, we also have k plus 1 plus 1 over 2 over 4. Right? Hope this is correct. Are we missing anything? Yeah, this is supposed to raise to power 3. Let's power 3. Hope this is correct. Hope this is correct, yeah. So what we do now, we expand. We expand. But remember this. You have to substitute the value of n here as this. So you'll be treating this as one variable, k plus 1 as one variable starting from this code. This as one variable starting from this code. Right? Hence, the expansion of this. The expansion of this will have to be k power 2 plus 2k plus 1 plus 1 power 2. You have to treat this way because this is the substituted value of this n for k plus 1. So you have to handle this way, right, in your expansion. Is that clear? Okay. So from this, you notice that everything here to k here is the same thing as what we have here. Hence, you substitute the value of this. Here. Hence, you have this. K plus 1 over 3 equals k plus 1 over 2. K plus 1 all over 4. Right? Now let's expand. Let's expand. First of all, let's just eliminate the 4. To do that, we multiply both sides with 4. And if we do that, we have what? We have k power 2. K plus k power 2 plus 4 k plus 1 power 3 equals k plus 1 power 2. K plus 1 plus 1 power 2. All over. Sorry. Because once you multiply 4 with this place, multiply 4 in the numerator, it will cancel out the 4 in the denominator, in this right hand side of the equation. So let's simplify. Now simplify and tell me if this, what we'll be having in the left hand side is the same thing as what we'll be having in the right hand side. Okay, let's simplify this thing together. Is there any way we can factor out? I'm just looking at this. Let me know if there is a way we can factor out.
Can we factor out k plus 1 squared in terms from everything?
I understand your point, but I'm also looking at the other side of the equation so that I can be able to show that the mathematical statement is true for what we are asked to do. What do you think? Okay.
So we divide out a k plus 1 squared.
K plus 1 squared.
Yeah, both sides.
So I want you to simplify this. Simplify this also. And let me know. Don't move anything. Just make sure that everything here remains here. Just want to apply the knowledge of all that we have been doing since this class. Here you apply binomial theory. any method, general method, Pascal's triangle, what do you call it? Combination method. And then you apply the basic law of properties of numbers and how to do your basic operations. Do the same thing here. I've asked you to treat this as this. I asked you to take notes. So distribute this, simplify this. Let's know if what we have in the left hand side is the same as what we have in the right hand side. Please do this in groups. Let's do this. Come on, let's go, let's go, let's go, let's go. Let's go. Let's go.
Which one?
Yeah, this one.
Okay.
Yeah, that one. Let's go, let's go, let's go, let's go. Last one. We have less than 2 minutes. Let's simplify, let's simplify. Be careful in all those operations. Because I can see so many more, I can see multiple cases. And are we done? Are we done? Thumbs up if you are done. Few persons. Very low percentage. Let's give 1 more minute. Let's be fast, please. Let's simplify. Remember, I didn't ask you to find K. I asked you to simplify everything that you have in the left hand side separately. And do the same thing for the right hand side. To its lowest possible thing. Just simplification. in the left hand side? What did we get in the left hand side? What did we get in the left hand side? What did we get?
K to the fourth.
Huh?
K to the fourth.
Okay. K what?
K to the fourth power
Okay. K to the fourth power.
plus 6K to the third power
Okay.
plus 8K to the second power
Okay.
plus 12K
Okay.
plus 4.
Plus 4. The other side, what about the other side?
You just barely got. We have I think 2K squared for the second.
We have what?
2K to the second
Uh-huh.
plus 4K
Plus 4K.
plus 3.
Plus 3.
That's what we got.
This is what it got. It shouldn't be. It shouldn't be. Okay. Did the other person get it? There's something different.
I got a 13k squared instead of 8.
Where?
K squared. Instead of 8k squared, I got 13k squared on the left hand side. Not done with the right hand side yet.
Okay. What about this?
It's gotta be the fourth power.
So, let's treat this first. Hence, you have what? You have k squared plus 2k plus 1 plus 2k plus 1 plus 2, thank you, plus 1. Hence, you have k squared plus 4k plus 4. Is that okay? Is that okay?
Yes.
Hence, you have here. You have here. K power 2 into k plus k squared plus 2k plus 1 plus 4 into k plus 1 into k squared plus 2k plus 1 equals k plus 1 into k squared plus 4k plus 4
Squared. K plus 1 squared on the right.
squared. Right?
Emmanuel.
That's good.
Emmanuel.
Good.
Emmanuel.
Emmanuel.
Nice. Let me write it this way. Let me write it this way. Emmanuel!
Couldn't you divide both sides by k plus 1 squared?
Yeah, I'm coming. Thank you. So here we have k plus k squared plus 2k plus 1 power 2. No, not power 2. Here we have k squared plus 4k plus 4. Right? Hence, you can divide both sides with this, this. Cancel out this, cancel out this, cancel out this. Now we'll be left with k power 2 plus 4 into k plus 1 equal to k over 2 plus 4k plus 4 equal to k over 2 plus 4k plus 4 equal to k over 2 plus 4k plus 4. Hence, what we have here is the same thing as what we have here. You can say that, hence, what we have in the left-hand side is the same thing as left-hand side, same thing as what we have in the right-hand side. Hence, say that the mathematical statement is true. Now, this is what we do with mathematical induction. Look at what I did here. I know that I actually rushed when I was trying to do some operations here. Look at what I did. First of all, I have to treat this because when I was substituting for k, this k for this n for k plus 1. When I substituted this for k plus 1, I have to treat this as a variable, as a whole, as a variable, right? So, I know that most of you must have made a mistake of treating this and making this to look like k plus 1 is 2. And you continue, right? No, which is not true. You have to treat this as a variable. That means this is a whole. That means you are multiplying this. This means k plus 1 plus 1. This raised to power 2. That means this is coming 2 times. Do you understand? So that's how I distributed this. And also, I needed to make sure that I don't even need to open up all this, but I needed to understand, I needed to separate this to make me see it better. Because k raised to power, k plus 1 raised to power 3 is the same thing as k plus 1 and k plus 1 raised to power 2. But since I already distributed this, and I know what this is, and I saw it here, I can actually replace this with this. That's what I did here. So I distributed this into 2 to have the first k plus 1 and also have the second k plus 1, now raised to power 2. Right? Then instead of writing this, I replace this with this, which is the same thing as what I have here. And also with this, which is the same thing as what I have here. Then I now discovered that I can divide both sides with everything here. K squared plus 2k plus 1. I did the same thing here. I eliminated all this and I was left with this. And this is now a very simple stuff to handle. Right? Hope this is clear. If you follow to this point, thumbs up. If you follow to this point. Okay. So, go to this. So, if given this 1 plus 3 plus 5, 2n minus 1 equals n squared. You have to show for solve this using mathematical to show for n equal to 1. You show 1, show for n equal to 1. 2. Assume for n equal to k. Then 3. Prove for what? N equal to k plus 1. Hence, we start from where do you start from? Start from proving for let n equal to 1. Let n equal to 1. You are picking the first term. And you are substituting 1 in the right hand side of the equation. You have 1 is equal to 1. We say let n equal to 2. You are picking the first two terms. 1 plus 3 equal to, you are now substituting the value of n inside here. You have 2 raised to power 2. Hence you have 4 equal to 4. This is also true for the second term. For the third term, you have let n equal to 3. Hence, you are proving for 1, 2, first term, second term, third term equal to, now substitute the value of n for 3. 3 power 2. Hence, here we have 9 equal to 9. So it has satisfied all these conditions. You move to the next step. So to the next step, you assume that it is true for what? N equal to k. Substitute the value of n for k. In this equation, you have 1 plus 3 plus 5 plus 2 k minus 1 equal to k squared. Hence you have what? You prove for what? N equal to k plus 1. Right, hence you have everything that we have here. Plus 5 plus 2 k minus 1 to the next step plus 2 k plus 1 minus 1 equals k plus 1 over 2. Right? We discover that everything from here to here is the same thing as what we have here to here. So we replace it with this. Hence you have k squared plus, let's distribute into this. Hence you have 2k plus 2 minus 1 equal to k squared plus 2k plus 1. Hence you have k squared plus 2k plus 1 equals k squared plus 2k plus 1. You can see that what we have here in the left hand side is the same thing as what we have in the right hand side. Hence, the mathematical statement is true. Hence, the mathematical statement well, if it's not the same, we say that the mathematical statement is not true. Just like when we are solving the equation, sometimes you can get 0, meaning that it has no solution. Is that clear? But most times you definitely